begin recording. Okay, so now we're recording. So again, we're talking about Chapter 9, Probability Categorical Data for the SAT Math section. So 9.1, Permutations and Combinations. Now this is a topic that sometimes gets put at the end of a math class. It sometimes gets left off. I definitely think it was left off in Algebra 2 last year because of the pandemic, and we just we had to quickly resort to remote learning. So I think this is something that was put on the chopping block, unfortunately. It's a pretty simple concept, and it's actually something you can do in the graphing calculator if you got one of these right here. And if you're missing a graphing calculator, maybe I'll put that in my poll for after today, because we could easily let you borrow one. We could put one in the lockers. You could pick it up and give it back to us later. Not a problem, because it's not like they're being used right now, right? So there's sitting collecting dust in one of the classrooms at Campbell. So anyway, what is going on here with all this stuff? So let's look at the first one here, fundamental counting principle. If an event can occur n different ways and another event can occur in n different ways, then there are m times n total ways that both events can occur. So let's actually use a deli example. So say you go to a deli or some sort of sandwich shop, right? And let's say you have m different meats. And so you have n different cheeses. And your plan is to make a meat and cheese sandwich, right? So let's say for meats, let's say you got turkey and roast beef, or RB for short. So you got ham. So you got salami. Let's say you got tuna. And well, I don't know, let's think of what's another meat we can do? Pastrami. There we go. Let's say for cheeses, we can get really crazy. I'm not a total cheese snob, but you can do cheddar, you do American, you do Swiss. Say you do maybe mozzarella. That's kind of weird. Maybe you could do provolone. We'll just stop there. 5 cheeses. Just there we go. So n, of course, is 6, and n, of course, is 5. So how many different sandwiches can I make? Assuming you're only going to pick one type of meat and one type of cheese. So it's going to be 30. You simply do m times n. 6 times 5, which is 30. You can do turkey with cheddar, or turkey with American, turkey with Swiss, turkey with mozzarella, turkey with provolone. So that's 5 sandwiches with turkey. Or you do roast beef with cheddar, roast beef with American, roast beef with Swiss, roast beef with mozzarella, roast beef with provolone. So another 5 ways. Or you do ham with all those, or salami, or tuna. So basically it's 6 times 5. Another example you could do is, like, let's say you go traveling and you have 3 shirts in your suitcase and 2 pairs of pants. Let's say you have a red, white, and blue shirt, and say you got jeans or slacks. So you can do the red shirt with the jeans, the white shirt with the jeans, the blue shirt with the jeans. Or you do the red shirt with the slacks, white shirt with the slacks, or blue shirt with the slacks. You're not gonna wear 2 pairs of pants at the same time, most likely. And you're probably not gonna wear 2 shirts unless you're really cold or you're kind of weird that way. But bottom line is you have 6 outfits you can make, 3 times 2. So that's called the fundamental counting principle. But the assumption is that you're only gonna pick one of each of those items from each group. Factorial is another useful strategy. A factorial is a mathematics symbol that has an exclamation point. Sometimes I jokingly say n really loud, or 4 really loud. If you see 4 factorial, you don't say it really loud. That's a dumb joke. All you do is you take the number and count down to 1. So you count down as like whole numbers, and you multiply it out. This can be very helpful. Say you have like 4 different colored. Actually, in my backyard by our swimming pool, we have 4 different colored chairs, and we can arrange them, in different orders, right? So this could be very helpful because let's say on the far left side of the pool, I put the yellow chair, and then I put the blue chair right after it, and then the red chair, and then the green chair. I don't know if, actually, I think we have a white chair. I can't remember. But anyway, we have these very colorful chairs in our backyard. But how many different ways can I arrange these chairs? Because maybe I start with the blue chair, and then yellow, and then white, then red, right? There's a lot of different ways I can do it. So for the first position, I have 4 options, because I have 4 different chairs to choose from. Then I have 3 options, because I've already chosen one chair to be, maybe the yellow chair went in the first spot, so now I got 3 more chairs to choose from to go in the second spot, then 2 and 1. And following the fundamental counting principle, I just multiply that out. Or if you so desire, you could just do this factorial, which is actually in the calculator. If you hit math and then PRB, you will see the exclamation point. So, or you can just multiply 4, 3, 2, 1. So not a big deal. But it's good to understand the exclamation point or the factorial because it does play a role in these 2 other formulas, permutations and combinations. Now, permutation is a way you can arrange something. So they use a word like arrangement. When you have n different objects and you're going to select R at a particular time. Let me give you a really good example. Baseball is a great example, actually. So in the game of baseball, and actually, let's do this. Actually, I'm kind of curious how the Giants are doing right now because they're playing baseball. I mean, that is my team, so we'll look at the Giants. I think they were winning. They were beating the Angels earlier. Even though they're having a pretty terrible season.
Mr. E, what do you think of Trevor Gott?
Trevor, for the Giants?
Yeah.
I actually, to be honest with you, I wasn't really paying attention yesterday. Did he have...
It was like 3 games during the A's. He blew it in the 9th.
Oh, the bullpen. Yes. I know the bullpen's been terrible.
Oh my, it's been awful.
Well, I look at bullpens collectively. I don't necessarily look at the individual. But yes, we have been pretty. Our bullpen. I think ours and Seattle's are probably 2 of the worst.
Yeah. Like the Cubs let up 5 homers in 3 games.
That's not good.
5 outs, I think.
Well, anyway, we don't want to spend too much time browsing this site, but like for example, you can see here like there's a bunch of different infielders, right? Like a bunch of different outfielders. But let's just assume that any of these guys could play any position. Like Brand Belt doesn't have to play first base; he could play left field. Or Evan Longoria doesn't have to play third base; maybe he could play shortstop. Of course, that wouldn't be a good idea to put like Pablo. Well, he did play catcher a long time ago. But let's just assume that any of these guys here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So apparently there are 15 guys who can play the field. So going back to this right here, n's the total number of different objects. You have total 15 different players, right? So you have 15 different players. Now in the game of baseball, you have 8 position players. You have a catcher, a first base. The second, actually, we could do it like a baseball diamond. Going back, talking about baseball again, I do like Mike Yastrzemski, though. He's been a really fun player to watch. So
I agree.
Yeah, his grandfather won a Triple Crown many years ago. When I first started following baseball, that was in 1987. I was about 10 years old. It was like the 20th anniversary of the Triple Crown. They were talking about, and then of course it happened for another, I think, 30 years after, or 25 years after, when Miguel Cabrera finally broke it. But anyway, I digress. So these are the positions, right? You have a catcher, a first base, second base, shortstop, a third base, right field, center field, left field. So those are all distinct positions, right? So obviously of these n people, I need to pick 8. I need to pick 8 of these 15 people to fill these different spots. So going back to here, obviously I have to, like, maybe I'll pick Chadwick Tromp and Brandon Belt and Evan Longoria and Pablo Sandoval and Donovan Solano Alex Dickerson, you know, so I got to pick these 8 guys. But once I pick those 8 guys, then I have to figure out where do they go, right? So say I pick Mike Yastrzemski. Does he go in right field? Does he go in center field? Does he go to catcher, first base? So the order or the arrangement kind of matters. When that matters, you're going to use a permutation. And so we do 15P8. And the formula goes like this. It's 15 factorial over 15 minus 8, or 7 factorial on the bottom. So the calculator can do this actually. If you go to math and then PRB, there's an option where it will do it for you. Not sure if the SAT will really necessarily ask you the specific question, but it's kind of good to know. And again, N is the total number of items to choose from. R is the number of items you're actually going to select from that group. So if I have 15 ball players to choose from, I want to pick 8 of them. But then of those 8, there's different orders or arrangements that matter. Now, if that doesn't matter, the order is not important, they would do something called a combination. So I'm using another sports example. Then I'm going to use food. Food is also a good example too, but I'll do another example. So going back to ESPN, so for those, I've actually been following the NBA. That's why I didn't know the question about Trevor Gott, because I've been following the NBA a little more closely. We'll look at the LA Lakers. They're the odds-on favorites. Actually, I think Portland's going to upset them, but we can talk about that later. But let's look at the Lakers, right? So the Lakers obviously have a bunch of players on the team. And actually, I want to click on roster. So if you count, you know, they have actually a lot of different players. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I know a couple of guys are injured, but we'll say they have 18 players, right? Now, the game of basketball, you have 5 guys on the court. And of course, you know, you have some guys like he's a point guard or the shooting guard. The bottom line is that the 5 guys are on the court. They're not going to be standing in any particular place, or they're not in any unique or distinct position. Really, it's just 5 guys on the court. And so in that case, I don't really care so much about whether I'm rearranging the 5 that I pick. So I have 18 guys to choose from, and I'm going to pick 5 of those guys. In this case, I use a combination. There's an extra term here. That extra term helps get rid of any kind of duplicate situations, I guess. Like, let's say I pick you know, LeBron James, Anthony Davis, Kyle Kuzma is another guy who starts. I think Contavious Caldwell-Pope. Sorry, now I'm using my. See, I really know my basketball very well. I can't remember who else is. Who else is starting? We'll say Alex Caruso. Anyway. This is maybe you don't know these guys. Maybe these 5 random names. So be it. If you don't know basketball, don't worry. But of these 5 guys, I'm not going to rearrange those 5 guys after that. Like, I just picked 5 guys and that's it. So in that case, that's why we have to divide by this extra term here to avoid any you know, I don't want to kind of like double count this this situation here. So you do 18 factorial over 5 factorial times 18 minus 5 factorial. Now, let me give you some other examples. Let's say, for example, in a classroom of like 20 students, I asked 3 of them to leave the classroom to go grab something from the library. You know, and again, like, you know, maybe they're carrying, they have to go pick up a giant projector, and all 3 of them are carrying it, right? But let's say I tell these guys, okay, I want you to, you know, so that case, that's just going to be a combination because I don't really have any distinct roles, right? Or if we talk about our SEC, our student leadership organization, like say there's 100 students to choose from, and we're going to pick 3, and they're all kind of the same role. But so that'd be a combination. But a permutation would be like, oh, 100 students, I want to pick 3, and someone's got to be the president, the vice president, and like the treasurer. In that case, I do need to do a permutation. Whereas the 20 students in my class, I told these 3 guys to go to the library, but I need one person to like pick up a box of pencils, another person to pick up the projector, another person to pick up a notepad. So those different roles, right? So in that case, I have to do a permutation. Another good example would be, so you're ordering a pizza. So say you got 20 toppings. So that's gonna be N, and you want a 3-topping pizza. Now, what do you guys think? Do you think this is gonna be a combination or a permutation? Do we really care? Well, let's say I pick like pepperoni, mushrooms, and olives. Will I care what order I put the toppings on the pizza? Like, do I have to put the pepperoni first and the mushrooms second, the olives third? Does that matter? Yes or no? No. So use a combination. Yep. You totally use a combination in that case. If you called the pizza place and said, you got to do this first and this second, they probably think you're crazy. So, or they probably won't listen to you. But anyway, so that's kind of giving a crash course. So if you didn't get that in your Algebra 2 class, now you do. So, and here's just some examples where they kind of go through that kind of stuff, like 4 roads from town A to town B, 3 roads from town B to town C. So how many different, and then you have to go back to a direction. So obviously you have 4 ways to get from town A to town B, then you have 3 ways to get from town B to town C, then on the way back from C to B, 3 ways, and B to A, 4 ways. Multiply it all out, those are all different routes you could take. Or, there are 2 chairs in a row, there are 5 cents, how many ways can the seats be filled? So obviously you have 5 cents to choose from, you got to pick 2 of those 5, and then of course order can matter. Or here, how many different groups of 2 cents can be formed? In this case, I'm not really rearranging anything, so it's just a combination. So that's, again, what's happening there. So I'll do, I guess, 1, 2, 3 with you guys. And 4, 5, 6, I'll put you guys in groups. So hiker's going to hike a mountain where there are 4 trails to the top of the mountain. And how many different ways can he hike up and down the mountain? So obviously there are 4 ways you can hike up and 4 ways you can hike down. So it's just 16 ways. And actually, if I were to kind of draw a mountain, because it's a crappy looking mountain, but here's one way, here's another way. Actually, let's do it kind of like that. So yeah, and then of course you go down each of those 4 paths. Now, let's say he does not want to take the same trail both ways. So in this case, 4 ways up and 3 ways down, because let's say he's chosen the blue way, so now that's out. So there's only 3 more ways left. And let's take a look at number 3. And then I'll have you guys do 4, 5, 6 in groups. How many ways can the letters of the word Sunday be arranged using only 3 of letters at a time? So we are rearranging the letters, because like, let's say I pick the first 3 letters, S-U-N, but then I could do S-N-U, or U-N-S, or U-S-N. There's a lot of different ways I could rearrange it, right? So in this case, I'm going to do a permutation, 6P3. And again, it's in the calculator under Math, PRB. If you don't have a calculator, not a big deal. You can just use the formula, which is on the previous page. And then you do 6 times 5 times 4 times 3 times 2 times 1. This was 3 factorial, 3 times 2 times 1. You just, cross them off. You multiply it out. And I think in this case, you get 120. So how do you guys do 4, 5, 6 in groups? Looks like how many people we got here? Good. So we'll just do 2 groups of 3, make it simple. I'll stop the